Today we're going to learn how to find angle measures using the angle addition postulate. My first example, I've given you the angle FEG. And if I write in here, this is 75 degrees. Little circle is again the symbol or the label for degrees. If I want to talk about the angle FEG, I would write it this way. And this would just mean I'm talking about angle again, FEG. If I want to talk about the measure of the angle, if I want to talk about the 75 degrees, I would have to put the little m that represents measure, and then you write it the same way, measure of angle FEG. So writing it this way allows you to talk about the measure of the angle FEG. And so the measure of the angle of FEG is just 75 degrees. So as we move on now, we're going to look at example 2. I'm going to tell you that the measure of angle JIL equals 30 degrees, and the measure of angle LIK equals 40 degrees. Whenever you're given measures for angles, it's always helpful to write them or list them in your picture. So this is 30 degrees, this is 40 degrees, and if I ask you the question, what is the measure of angle JIK? I'm asking, what is that? You should, again, just like our segment addition, you should be able to kind of figure that out right away, but I want to be, again, methodical about how we do it. You'd say the measure of HIK equals the measure of angle JIL. So again, reminder, JIL is this piece, and I am just adding that measure to the measure of angle LIK. So I'm adding it to this piece. And again, you should be able to look at that and say, well, the measure of JIL is 30 degrees, and the measure of LIK is 40 degrees, so the measure of angle JIK, if I do my algebra correctly, is 70 degrees. So whenever they ask you the measure, you're going to just add together the angles. They have to be touching. Notice these two angles overlap at that green point. Same thing as we move on to example 3. In example 3, I'm going to tell you that the measure of angle NMP is 120 degrees. So again, following that, that's NMP. So the whole angle is 120 degrees. And you kind of write that off to the side because it's divided up. And then I'm going to tell you the measure of angle OMP is 48 degrees. So OMP, this angle is 48 degrees. And what I would like to know is I'd like to know what's the measure of angle NM. Again, put that vertex in the middle, NMO. What is the measure of that angle? So again, doing our method that before, you're always going to take the largest angle, or the whole angle. Kind of looking back up here, the whole angle was JIK. We're going to take the whole angle, which is the measure of angle NMP. We're going to add together then the measure of angle NMO plus the measure of angle OMP. We know that this one is 120 degrees, so we're really using our substitution property right here. We know that this one, given the information I told you, this is 48 degrees. So you should be able to quickly realize that you just subtract 48 from both sides. So minus 48 degrees, minus 48 degrees, that you're left with 72 degrees for the measure of angle NMO. So adding together the angles, this is considered the angle addition postulate. In my last example, I'm going to tell you that angle, the measure of angle TQR is 115 degrees. So again, it helps to kind of like draw that out. So TQR, this is 115 degrees. I'm then going to tell you that the measure of angle TQS, so again looking at that TQS is 3x plus 2 degrees. And you write it in parentheses so the degrees are applied to everything. The measure of angle SQR, again SQR, the measure of angle SQR is 2x plus 3 degrees. So again, whenever you find out what they're labeled or what their measures are, so you write it. So I'm going to write this one as 3x plus 2 degrees, and I write this one as 2x plus 3 degrees. And we want to find out the value of what is the measure in degrees of TQS, and what is the measure of angle SQR. How many degrees are each of those angles? So since we have an entire angle here, following our angle addition postulate, you take the entire angle, angle TQR, and how is that formed? It was formed by the measure of angle TQS plus the measure of angle SQR. We were told that this is 115 degrees, so substitute that in. We are told that TQS is 3x plus 2 degrees, and we are told that the measure of SQR is 2x plus 3 degrees. So now using all of our properties from this year, 115 degrees. Remember there's an imaginary 1 out front, so we're going to distribute the 1 to eliminate the parentheses. We're going to combine the like terms. So we have 3x's, 2x's for a total of 5x. We have 2 and 3 for a total of 5 constant. We're going to subtract 5 from both sides, so I get 110 equals 5x, and we're going to divide by 5. If you divide 110 by 5, you get 22 equals x. So x equals 22, but that's not the question that we were asked. We were asked what are the angle measures. So we're going to use our substitution property. We again know that this was 3x plus 2. So we're going to substitute in the 22. So 3 times 22 plus 2. So 3 times 22 plus 2, I come up with 68 degrees. Do the same thing, I'm going to substitute in for x. So I have 2 times 22 plus 3. So 22 times 2 is 44, plus 3 is 47. So I have 47 degrees. So if I go back to my picture, I just found out this was 68 degrees, and this was 47 degrees. Now mathematicians are not very good at drawing to scale, so you follow what's listed or what's given to you. And then you should verify. If I add 68 degrees plus 47 degrees, does that equal 115 degrees? Well, if I add 68 plus 47, yes, 115 is on this side and that equals itself. So these are the measures of my angles, and I use the segment addition postulate. We're going to ask you to do a few more problems on a worksheet, and then you can turn those into the basket to review how to add angles.